Welcome back to the ECL online training series and lesson 6, basic ECL syntax. Now in the first 5 lessons we spent some time downloading the HPCC VM, and so hopefully now you have a target cluster on your local machine, or maybe you have access to an available cluster that's configured within your company. But nevertheless, we've also set up the ECL IDE, talked about the ECL watch, and so now we're ready to dive into some of the basics of the ECL language. This lesson is a short one, but nevertheless is very important as it covers some essential concepts of ECL. First of all, you need to know that ECL is a declarative language, and the majority of statements in an ECL file are made up of many ECL definitions. An ECL definition is the basic building block of ECL. A definition asserts that something is true. It defines what is done, but not how it is to be done. Definitions can be thought of as a highly developed form of macro substitution, making each succeeding definition more and more highly leveraged upon the work that has gone before it. This results in extremely efficient query construction. David Bayless, our chief data scientist, says when you're thinking of ECL, don't think of ECL, the language, as how to do something, but what data do you need? So in this slide, the simplest form of an ECL definition starts with a name and what we call the ECL definition operator, and we always read that as is defined as, and to the right of the definition operator we have any expression. The name must begin with a letter and may only contain letters, numbers, and underscores. The colon equals operator is always read as is defined as, and the expression must define either a single value calculation, a Boolean true-false condition, a set of values, or a set of records. And in ECL, the semicolon is the required ECL definition terminator. Now here's some more essentials of the ECL language. When we talk about case sensitivity and formatting and comments, the good news about ECL is not case sensitive. White spaces are also ignored, which allows custom formatting for good readability of your ECL. Single line comments begin with a double // and block comments are delimited with a /* and an */. There's hotkeys also in the environment. Control Q is the hotkey for single line comments, and the Control Shift Q is the hotkey for block comments. Finally, ECL uses object.property syntax to qualify scope and disambiguate references within tables. Now, we could have a last name that is stored in many different data files across the cluster. So I might have a last name that's associated with a relatives file. I might have a last name that's associated with a persons file. So to disambiguate between the two, I simply need to say persons.lastname or relatives.lastname. And in the last slide here, let's take another look at an ECL definition, but this time discuss all of the options available for any ECL definition. Starting on the far left, we talk about the word scope. Scoping refers to an ECL's definition's visibility to other definitions. An ECL definition with the export keyword, which is shown here, is available globally throughout its own module and in any other module that imports its module. It must be fully qualified. An ECL definition with the shared keyword is only available throughout its own module, and we'll talk much more on this later in an upcoming lesson. Finally, any definition without an explicit scope, neither export nor shared, is implicitly a local definition and is available only within other export or shared definitions. Next, after scope, we see a value type. We will talk about many value types in upcoming lessons, but for now you only need to understand that setting an explicit value type will be useful in ensuring that what you are expecting to return for your definition will not be misinterpreted by the compiler. In other words, if you happen to make a coding error that could return some other value type, explicitly defining one will make sure that the compiler can catch a coding error. When a name passes parameters to the expression, the basic ECL definition becomes a basic ECL function, and we will discuss these functions in an upcoming lesson. And finally, after the expression, any ECL definition can also include a workflow service. Now, workflow control within ECL is generally handled automatically by the system. It spots which processes can happen in parallel, when synchronization is required, and when processes must happen in series. These workflow services allow exceptions to the normal flow of execution to be specified by the programmer to give extra control, such as the stored clause shown here. Workflow operations are implicitly evaluated in a separate global scope from the code to which it is attached. Therefore, any values from the code to which it is attached, such as a loop counter, are unavailable to the workflow service. In the next few lessons, we will now expand and discuss much more ECL basics. But to review though, the basic definition always starts with a name on the left side, followed by the definition operator, which is the colon equal and read as is defined as, and the expression. So to read this seemingly complex expression here, we would simply say is leap year is defined as year modulus 4 is equal to 0 and year modulus 100 is not equal to 0, or year modulus 400 is equal to 0. Okay, that's all for now. Thanks for watching, and we'll see you in Lesson 7. Thank you.